Hi everybody, my name is Ben Pearce and I am here with the most awesome Kate Rosenshine.
Hello, Ben Pearce.
Hello. And we're going to be having a conversation about AI ethics and responsible AI. Now before we get into that, Kate, can I get you to introduce yourself?
Of course. I am Kate Rosenshine. I head up a team of cloud solution architects focused on data and AI, covering financial services. So my team works on everything from data platform through to AI and all the fun stuff in between.
Excellent. Now, we're not going to have a deep technical conversation today, but before we get into talking about responsible AI and ethical AI, maybe it's worth just spending a little time thinking about how data and AI go together and just, level setting a little bit. So could you level set for us?
Yeah, I mean, so let's start talking about the data, right? And what AI actually is and what we talk about when we talk about systems or machines that are thinking. So fundamentally, we have large sets of data which we feed into systems that use algorithms to iterate on themselves to get to a certain goal that we predefine. Right? So a statistical outcome for that predefined goal of a probability. Right? So basically, you're taking data, feeding it into the system and getting a probabilistic outcome. So when we talk about machines that are thinking, they're not actually thinking like we as humans think. They are making statistical assumptions based on the data that we feed.
Okay, so there's a huge correlation between the outcomes that machine learning will deliver and the data that it's trained it. So I wonder,
it all starts with the data, Ben.
It all starts
with the data.
So have you got any examples where perhaps data has been misinterpreted that if used in the wrong way could then lead to bad outcomes?
Yeah, so a very canonical example is the one from a 2015 study that used data. So a bunch of researchers took some data from hospitalizations and tried to see what outcomes patients would have with certain conditions when they were admitted for pneumonia. Okay, so someone is admitted for pneumonia. What are the odds of complications based on other conditions that they may or may not have. And what these researchers found was that people with asthma were less likely to get complications from pneumonia.
Which sounds a bit odd.
It does sound odd.
Because both of those are lung-affecting conditions. So you'd have thought if you've got asthma and pneumonia, the two together would be really bad.
Probably bad, yes.
Yeah.
Yes, and indeed they are. So what they thought the same as you. So when a doctor would look at these results, that would be strange. And basically this data represented patients that were admitted to hospital. And patients with asthma were not admitted because they went to the top of the line. They got that sort of treatment in advance, and therefore they weren't accurately represented in the data set.
So they're actually a super high risk group.
Exactly.
And as soon as a doctor sees asthma and pneumonia together,
no questions asked.
Straight in. But that means therefore they were then their health issues were solved. So when you look at the data at the end, it shows no correlation or low risk between asthma and pneumonia because
And if you understand that data, that's fine. But if you don't, right? If you just use that model and it's probability still, and you're making healthcare decisions, right? Do I treat these patients or not? And you say, well, actually, I shouldn't invest in treating patients with asthma because they're going to be fine, right? So it's that understanding of the data that you're feeding into the system and what the goal, what the outcome that is required from the system will
and the
be.
Human overlay of common sense over that.
Well, yes. Whenever I say humans have common sense, I get a few giggles. But yes.
Now, the other thing I hear a lot with data is about data bias. Have you got any examples of data bias at all?
Yeah. So I think. First of all, it's important to remember how data is created. And data collection is not a science, and data reflects our society. Right? And that changes over time, and that also changes over geography. And just to give you one example of a data set, there's one data set that represents human activities.
Okay.
And the data set was created so that people can use this data set to train models for machine learning.
Okay.
And the people that created this data set used movies to determine how people behave.
Right, because movies really represent my life. Yours as well?
I mean, mine for sure. I don't know about yours, but yes. If you look at my life, it is very representative. But if you look at the data, right, and you look at, let's take men, for example, because I think we talk a lot about females and minorities, but what about the men?
So men in movies.
Men in movies.
Okay.
If you look at the data set for person hitting person or person kicking person as well, what are you going to find?
I don't know.
A bunch of men.
Right.
Chopping.
Okay.
Karate chopping a bunch of other stuff.
Okay.
Men.
Right.
Various items.
Yeah.
And that doesn't really represent what I guess most men do on a day-to-day basis. I don't know. I mean, I've never seen you karate chop anything, Ben. So
basically,
maybe I'm
because
wrong.
the data set was movies, there's lots of action movies. Looking at behaviour of men in movies, it's a lot of karate chopping and a lot of punching and a lot of kicking. And maybe that doesn't represent other men.
Maybe, I don't know.
In society.
But it depends on how you use that data, right?
Yeah.
So if you're using that data to make certain assumptions or make certain decisions, might not be a great idea.
But if you're looking for that to look at outcomes on what's successful in movies, that's absolutely
maybe
fine.
that could be
But
fun. I don't
predicting
know.
what a man might actually do in real life would be a terrible use of that data because of the biases that are in there.
Yes.
Right. Okay.
Well, yes, and how it was created.
Yeah,
Right.
yeah,
So understanding what the data is
Yeah.
fundamental to any AI system.
Okay. So that takes us on to another point then. So you've got people creating the data. You've got then data scientists that are taking that data and applying models to it. Then that model is then normally part of a bigger developed solution, and then that solution is then used by end users that are using that. So the decisions that are made and the outcomes that are made, who's accountable? Who's responsible, given all of that complexity, for whether the right decision is made?
That is a great question.
Okay.
And this is something organizations think about a lot.
Okay.
I think when it comes down to it, if someone makes a certain decision, they can't go back and say, well, the algorithm told me to do this.
Okay. Yeah.
I don't think that would fly.
Yeah. And given that the algorithm was then trained on the data, the algorithm designer is going to say, well, it was based on the data that came to me.
Exactly.
Right. Yeah.
Exactly.
Yeah.
So
Right.
what are you going to do? One of the challenges that a lot of organizations face, though, is that the people that create these systems don't necessarily understand the context in which they will be used, and vice versa. The people that are using the systems don't necessarily understand how these systems are created. So for example, when we think about loans, which is a very common example that people use a lot, if you are the person deciding whether to give someone a loan or not, and you use an AI system to make that decision, how do you know what the risk is, right? How do you understand that system that you're using as one of the various other data points that you might be using to make that decision?
Okay.
On the other hand, if you're creating that system, how do you understand how that will be used to make decisions that will affect people's lives? And the reason I'm using loans is that could have an impact.
Yeah, on people's lives.
Exactly.
Yeah.
On that outcome has a very tangible impact. If you refuse someone a loan, that could be pretty bad, right?
And so it's important, therefore, I guess, that you're able to explain and justify why that decision's made.
Yes, absolutely. So I think that's something organizations still think about. I think there is a need to understand a bit of both when you make these decisions. So I think data is becoming something that has to be more common knowledge for people that are consuming these systems. And another part of that is creating that operations, the governance for these systems, and traditionally, or what we've seen so far, is a lot of data scientists having a lot of fun with data, which is great. It's a lot of fun. Yeah. But when you think about operationalizing at a certain scale, you need that end-to-end cycle. So what we see a lot now, especially in regulated industries where they need to have that traceability, a big trend is machine learning ops. So like DevOps for machine learning.
Okay.
And that gives organizations the capacity to go back and understand how certain decisions were created.
Yeah, okay. So I guess what's sort of coming out from here, I can hear, is there's a lot about humans working with the AI and applying that kind of common sense on top of it, and also then some robust processes.
We'll call it judgment.
We'll
call it judgment because, yes.
So some good judgment from humans, and then also some robust kind of processes and policies and governance in there. That's really important. And just having thought about this, because if you just go off without having thought about any of these things, you can find yourself in a really difficult situation just by not knowing what was going on.
Yes. And what do we always say, Ben?
I don't know. What do we always say?
Well, just because we can.
Doesn't mean we should.
There we go.
Yeah, I know that one. Right. So there's something in there also then about skills. So what do you think, as people start getting into enterprise, production, artificial intelligence, what are the sort of future skills that you think people need to start investing in around this?
Yeah, so I think basic technical literacy is becoming more and more important.
Okay.
The good news is coding has become a lot more accessible.
Okay.
It's a lot, and languages like Python use a certain logic that's a lot easier to get into than what coding was.
Assembler was what I remember doing that at university. That was not easy to get into.
I remember I had the joy of Pascal followed by MATLAB.
So the coding's a bit easier.
That was fun, and then I learned Python, and I was like, "Oh my God, this is great!" It tells you when you made a mistake. But I think that's a big part of it. Yeah. But also, in addition to having those technical skills, and it is just a language, it's that sort of empathy and understanding of these systems, the need for judgment, and the need for creativity that are uniquely human skills that will have to be infused into these systems. So when we talk about bias, for example, if you're just looking at the technical problem and not thinking of the context of society, you might be creating systems that could potentially harm.
Okay, and so what we're putting up on the screen now, just some examples. There are a number of white papers, some from Microsoft. There's lots else out there that really talk about not only the technology side, but the process side, and then the ethics and the responsibility side. It's important to think about these sort of things.
It's very important.
Well, thank you very much for listening. Hopefully you've enjoyed our conversation. We've enjoyed having a bit of a chat. So if you've got any questions, please do just let Kate or I know. If not, thank you for listening and take care.